Hi, we're going to do a lesson on trig functions and SOHCAHTOA. We're going to try to solve right triangles. We're going to try to solve what it means to solve right triangles is getting the length of the sides or the different measures of angles. So let me share my screen with you and we'll get started. Okay, so this is our presentation. Again, what is a right triangle? A right triangle is a triangle with one 90-degree angle. And remember, it could only have one 90-degree angle because triangles could only have a total of 180 degrees, right? And so if you had two right angles, that would take up, both angles would take up all the degrees. And so you wouldn't have enough for the third angle. So you need, any right triangle can only have one right angle. All right, so when we start with this presentation, when we start with this, we have to make sure that we understand the acronym SOHCAHTOA. And I'm sure you've heard of this before. So is spelled S-O-H, Ka is C-A-H, and TOA is T-O-A. Okay. It sounds very, I don't know, it's very smooth. A lot of people understand and remember it. And so this is just a way of remembering how to solve these right triangles. So means sine, the S means sine, okay? The opposite, the O means opposite, the H is the hypotenuse, okay? The C is the cosine, which is spelled with the C-O-S. And then of an angle, we'll just call it theta. A lot of people just use theta. It looks like a complicated sign, but just remember, kind of look past that. It's just the angle letter pretty much, equals adjacent over hypotenuse. Okay. And the TOA is the tangent of an angle is equal to the opposite over adjacent. Okay, now what does this all mean? Okay, well, let's look at this triangle right here. We have this triangle ABC, and we're looking for this angle right here, this X angle. Okay, well, what is its opposite? What is its adjacent? And what is its hypotenuse? Okay, the easiest part to spot out is the hypotenuse. The hypotenuse is always the longest side of a right triangle. Okay, and so you look at the 90-degree angle. Okay, and the side that's opposite. You see how this 90-degree angle, right? You see how this 90-degree angle hits this side and this side? Well, it's the one side it doesn't touch. Okay, or you can just spot the longer side. So the 25 is the hypotenuse. Okay. Now let's look at this angle right here. Okay. And if we're asking for the opposite of this angle, well, you see how this angle touches this side and this side? Well, it's the side it does not touch. So 12 would be its opposite. Okay. If I was trying to get angle A here, okay, and I wanted to spot its opposite, see how this angle touches this side and this side? Well, it's again, the one side it doesn't touch. So this side would be the opposite. Okay. So the sine of X, or you could call it the sine of C, either way is fine in this situation because they labeled it X or C. Remember, you're trying to get this angle. The sine of X is equal to the opposite, which is 12 over 25. Okay, the cosine of X is equal to its adjacent. Adjacent is the side that is the angle is connected to. But you see how like this angle right here is connected to this hypotenuse and this side right here. Well, we know this is the hypotenuse, so this has to be the adjacent. So we'll call this, I don't know, we'll call this B, small b. And so it'll be B over hypotenuse, which is 25. Okay? And then the tangent of X, or the tangent of C, is equal to opposite, which is 12 over X. Or sorry, B, my fault, B. Okay? So understand where the opposite is, where the adjacent is, so on and so forth. Okay? So let's look at this example here. Okay? We have the sine here, the sine of 30 degrees. The sine of 30 degrees is equal to its opposite over hypotenuse. So the opposite is x, and the hypotenuse is 10. What if we got the sine of this? Now we know that because this is 90, this is 30, and since a triangle has 180 degrees, we know this is 60 degrees. Now let's call this side y. Well, what is the sine of 60 here? The sine of 60 is, this is the opposite, which is y over the hypotenuse, which is 10. Now let me ask you this, what is the cosine of these same degrees? So let's say the cosine of 30 degrees is equal to, well, the adjacent is y and the hypotenuse is 10. Remember, the adjacent is, see how this angle touches this side and this side? Well, since we know that this side is the hypotenuse, this side has to be the adjacent, okay? Because how do we know this is the hypotenuse? Because here's a 90-degree angle, right? This 90-degree angle touches this side and this side. So the 10, this side, this long side is the one side the 90-degree angle does not touch, okay? The cosine of 60 degrees is equal to its adjacent, which is x over 10. Okay, hopefully you're making these connections here. Okay, let's look at this part right here. This part right here is the cosine of 50 degrees. So what they did was the adjacent is, so here's the 50 degrees, this angle. This is the adjacent because we know this is the hypotenuse. That's why it's y over 25. If we got the sine of 50 degrees, all right, that would equal what? The opposite, let's call this x, x over 25. If we got the sine of 40 degrees, now why did I get 40? Because we know that this is 90, this is 50, you subtract it to 180, and we know that this is 40 degrees right here. So the sine of 40 degrees is equal to y over 25. All right, how about the cosine of 40? The cosine of 40 is equal to adjacent, which is x over 25. All right, the tangent of 40 is, remember, the opposite over the adjacent. So the opposite is y, the adjacent is x, so it would equal y over x. Okay, so that's how you form these trig ratios. Okay, now let's use these trig ratios to solve these triangles. Okay, like what I mean by solving triangles is, what is the x, what is the y, what are the side lengths, and what are the angle measures? That's what we're trying to do. Again, in all these terms, you just have to understand the meaning of this, and then you'll understand, it'll be a lot easier for you to pick up. Okay, so let's do what they've given us. Let's just use the example that they've given us. Okay, so if I have the sine of 30, right, we form this trig ratio, sine of 30 equals opposite over hypotenuse. Okay, what we have to do is, first of all, we have to get the sine of 30. Now, how do we get that? You need to use your calculator. Okay, now this gets kind of tricky because some calculators, you have to enter the number first and then press sine, or you have to press, other calculators where you press sine and then put 30 in. If you see any sort of like parentheses, usually it means press the sine button and then push 30. So make sure, first of all, that you have a scientific calculator on you. Okay, I'm using my iPhone calculator right here. Okay, and I'm going to clear this. Okay, so in the iPhone calculator, and make sure you're in the degrees mode. How do you know if you're in degrees mode? Well, press the rad button. If the rad button comes up in the iPhone calculator, that means that you're in radians. You want to make sure that rad button's off. So you just have to just press that DEG button. Okay. Make sure that you press 30 and then press the sign button, and you should get the answer 0.5. Okay, and that's how I got this right here. All right. Then it's like solving an equation from there. It's not that hard. Okay, so you're pretty much going to multiply both sides by 10. And what do you know? That x is equal to 5. And remember, it's not degrees because it's not an angle. It's a side length that we're getting. All right. So same thing here with number 2. All right, we have the cosine of 50. All right, so when you get it in your calculator, just press on an iPhone calculator, press 50 and then press cosine. You should get something like 0.643. Okay, I would round it to the nearest, I guess, thousandth place, because the more decimal places you have, the more accurate your answer is going to be. Okay, and then multiply both sides by 25, because again, you're solving the equation, right? And you get y is equal to 16.075. Okay, let's go on to the next problem. I'll give you a few of these examples. All right, so let's do this one. Okay, all right, so we have the angle 38, and we have an h right here, and we have 15. So which trig function would we use? Well, we need to find the opposite, and we have the hypotenuse. So that should automatically trigger you to understand that you should be using sine for this. So sine of 38 degrees is equal to h over 15, right? Okay, and so if you have the sine of 38, let's see the sine of 38. 38 degrees would be, so 38 and then press sine, oops, 38, press sine. I have 0.6156, so I'll probably just do 0.615, I guess 7 equals h over 15. And then I multiply both sides by 15. And you get, so multiply this by 15. Oops. Multiply it by 15. And you should get something to the extent of h is equal to 9.23. Okay. Keep in mind too that the hypotenuse is the longest side of a right triangle. And since you're solving for h, and if you get a number higher than 15, the hypotenuse, you did something wrong, because again, this has to be the longest side. Okay. What if now, let me kind of flip the tables a little bit here. What if I changed the problem and I had 15 here, and this is x. This is what we're looking for. Okay, the hypotenuse is what we're looking for. Okay, well, you'd use the sign again, right? Because you have the opposite and the hypotenuse. So the sine of 38 is equal to, in this case though, it's 15 over x. So what would you do in this situation? Almost the exact same, but it's a different method of solving it out. So you would get the sine of 38 again, which is 0.6157 is equal to 15x. However, the reason why I'm mentioning this is because instead of multiplying the 15, so remember, you're solving the equation, you would have to multiply by x to both sides here. Cancel this out. People like to think cross multiplication too, that's fine. This becomes 0.6157x is equal to 15. And then you divide this by 0.6157. So when you do that, it's 15 divided by 0.6157. You get approximately, so x is equal to 24.36. Okay, and it makes sense, right? Because this answer should be bigger than this answer because this is the hypotenuse. All right, let's do another problem. Let's do one more problem. Go to the next slide. This time, you're going to kind of be working a little bit backwards. You have the side lengths, but you want to find the angle, okay? You want to find the angle. So you have 10 and 6, and you need to find this angle right here. Well, right now we have the 6 here, right? And we have the 10 here. And this is the opposite of this angle, right? And this is the hypotenuse. So again, we're going to use a sine function. So the sine function, sine of, they call this theta. Again, don't be so worried about the labeling. It could be the sine of A. Remember, you're just trying to look for the number of degrees for this angle is equal to 6 over 10. Okay. Now, this process is going to be a little bit different because you're finding the angle. And when you want to find the angle, you have to use that second button. You should see that second button on the top, okay? Or it could say INV, the inverse. So using the inverse function of the sine, okay? Because you're trying to find the angle. So it should look something, you should have some sort of -1. You should see that somewhere. And remember, it has to be in degrees. You want it in degrees, okay? So what I'm going to do is I'm going to plug in 6 divided by 10. So 6 divided by 10 is 0.6, okay? Then I'm going to press second and then sine, and you should get 36 point something, 36.86. Okay, so again, if you're using an iPhone calculator, 6 divided by 10, which is 0.6, so this ends up being sine of theta is equal to 0.6. And then remember, press second, sine, and that -1 should pop up of this number, and you're going to get 36.86 degrees. Okay. Forgot to mention that this is the right angle right here. Okay. If you want to use cosine, let's just say the theta is here. Well, let's call this, for the sake of, let's call this y. If we want to find this angle, okay, we could use the cosine, right? It's cosine of y is equal to the adjacent is 6 over 10. Okay, all right. So if we use the cosine, remember you're doing the same thing. It's 6 divided by 10, which is 0.6, right? So this ends up being cosine of y is equal to 0.6. And then what you're going to do, again, press second, sine. But since we already pressed second, as long as it's highlighted, you're good. Okay, and then it has to have that -1, that -1 over the cosine. As long as it has that, you don't have to press it. You don't have to press second again. And so second cosine, just press that, and it should be 53.13. Okay, sorry, this is a little messy. 53.13. Okay. So make sure that you're using these functions, okay? There's also multiple ways of finding side lengths and angles. So in this case right here, since we had 2 of the side lengths, 10 and 6, you could use the Pythagorean theorem to find this side right here, okay? And then you know how we got the 36.86 right here? Well, you don't need to do the cosine because you could just add 90 and this and to get subtracted to 180 to find this angle as well. Okay, so again, there are multiple ways of solving right triangles, right? Try to use all those tools. Whatever's easier for you, that's the way you want to use it. That's fine. Okay, Hope this helps. Again, if you have any questions, please let me know. Thank you. Bye.